Good afternoon, everyone. My name is Andrew Old. I'd like to introduce my colleague, Ruby Sealey-Lawson. We both work for Ballance Agri-Nutrients. We're going to be discussing the processing behind SuperAir's SpreadSmart tool, and in essence, using FME to make geospatial data fly. So what we're going to go over is a brief intro of who Ballance and SuperAir are. We will go over what SpreadSmart is. We will go through our old process to create SpreadSmart maps and how we process the data. Ruby will also go through the new process where we utilize FME, and then we will talk about integrations and any takeaways that we've got through the process of, or in the project, using FME in the project, and also our takeaways of FME in general. So with that in mind, who is Ballance and SuperAir? So Ballance Agri-Nutrients is a 100% farmer-owned cooperative. We have a nationwide footprint and are based in Tauranga. Ballance manufactures fertiliser nutrients to help New Zealand farmers grow food by providing products and advice with tools to promote sustainable farming. Now, SuperAir, on the other hand, is a fully owned subsidiary of Ballance. They provide an aerial top dressing service. If you don't know what aerial top dressing is, it is basically a method to aerially apply fertiliser nutrients over predominantly hill country farms using aircraft. So on these slides, we've got a few photos of some of the planes in action. So on the slide at the bottom there, you've got, that's a yellow aircraft flying fertiliser over the farmland. I think the other name for that that is used overseas is crop dusting. So SuperAir, it has a nationwide coverage and owns 18 aircraft throughout New Zealand, of which 15 are capable to run the SpreadSmart service. I'll now just pass it on to Ruby, who will talk about SpreadSmart.
So SpreadSmart is a system that combines GPS guidance with digital mapping technology to automate the control of fertiliser flow from an aircraft hopper while in flight. And our geospatial team produces the SpreadSmart data that is loaded into the plane, such as the aspect map, which is the first image shown on this slide. In this example, the plane would fly over the farm, referencing the map and spreading more fertiliser on the red north-facing land and less on the blue south-facing land. And then no fertiliser is spread on the exclusion zones, which are the trees, rivers, and buildings. So the first image is the input we create from our process. And the second image is the output that the plane puts out, which is where showing where the fertiliser has been spread across the farm. In a nutshell, SpreadSmart is enabling a smarter fertiliser application option for farmers to ensure the right products are spread in the right place. I'll pass over to Andrew to explain how we used to generate SpreadSmart maps pre-FME.
So before we implemented FME into Ballance, we had a process to create SpreadSmart maps that were predominantly using Esri tools in a very disparate way. So firstly, we had to obtain the farm map, and this could come from a number of places, like the farmer could submit it to us, or we could get it off the track map system, which SuperAir used to control their spreads, or we could get it through Balance's own customer-facing portal called My Ballance. So once we've got that farm map, we could then put it into the machine learning tool to identify any exclusion zones, and that's usually trees or gullies where fertiliser, the farmers don't want fertiliser to be placed. The output of these exclusion zones was then verified for quality. Once the verification process was done, we then had to run it through a number of other models, builder scripts to generate spread patterns based on things like slope or aspect or whatever the farmer wanted to build them onto. after we'd created these spread patterns, then the data was then run through a number of other Python scripts to generate PDFs and shapefiles. So, and these were all bundled up and passed to SuperAir. So it was quite an inefficient process, and it required a number of data handling touch points. And we had a high reliance on analyst time as well, whereas this could be quite a good automated process. We were running processes locally on laptops and passing data as individual files, so there was risk of losing things, and yeah. Basically, each job was taking between 1 to 4 hours as well, so it was very time consuming and inefficient. So Ruby will now just take you through the new process where we introduced FME.
So with the inefficiencies that Andrew has just described in the old process, we decided to engage with Abley, who are our location technology partner, to work on streamlining our processes in FME. The result was 2 FME workbenches that run on FME server with a custom front-end mapping application wrapping around that process. In the application, the user can select a farm map from our internal database or upload their own map. The user inputs are then pushed through to stage 1 in FME server. And in stage 1, the exclusion zones are generated, such as trees on farm. The trees are generated by a machine learning process that runs via a Python script. So we have FME submitting data to initiate that Python script, as well as locating the output data from the script to write to a geodatabase. That's where we come to our first and only manual touch point for the geospatial team in the new process, which is to check the machine learning output accuracy. Our team knows when that data is ready for checking, as we've utilised FME's emailing capability to send a notification email out. FME is also capturing the status of every job submitted via the application in a table, which includes information around which SuperAir users are requesting maps, what date they're requesting a map, and the status of the job as it moves through the FME process. That job table is checked every half hour by a scheduled process on FME server. If certain fields in the table meet the correct criteria, then FME knows that the machine learning data has been checked by an analyst and it's ready to move into stage 2. In stage 2, FME generates the customized spread maps for SuperAir, including the slope and aspect, for example. It also generates some additional maps that show other features of the landscape to our farmers, such as elevation, bridges, and gullies. Once the final data outputs are complete, they're written into a geodatabase, and the SuperAir user is notified via an email from FME that their maps are ready. The user then goes back to their application in the front end where they can view, print, or export their map data. The immediate wins for the Ballance geospatial team were in processing time improvement. The time a job spends on FME server was about 15 to 30 minutes, depending on farm size. We found that it took approximately 1 minute for 1,000 hectares of farm to process through stage 2. In comparison, the old process with Model Builder, sometimes a 30,000 hectare farm could take at least 4 hours to process, whereas in FME that would be half an hour. Moving on to looking at our FME integrations in this project, we've got a bit of a list to go through. So starting out, we have a ArcGIS Experience Builder user interface, which is our mapping application as pictured on the slide. And this uses a custom integration layer that authenticates requests via Esri tokens. This is where we capture the user data that we put against each job. The application connects to FME via the FME server API. The 2 workbenches read in both internal and external data inputs. One example is we have a BW lookup against our customer data that assigns property information to each job. And we also read in external data such as the New Zealand building outlines to identify buildings to not spread fertiliser on. And these building outlines are updated weekly with a scheduled update. As mentioned earlier, the data is being sent to and received back from an external machine learning Python script, and we also have that scheduled data check against the job table to track the status of the process. We did run into a couple of challenges when we moved from the old process to the new process. One of those was that we found that some of the Esri tools available in ArcGIS Pro were actually better than the FME tools. So one way we got around that was to call an ArcPy script to run some Esri DEM tools for identifying ridges and gullies. We also found that the Eliminate tool in Esri was really difficult to replicate in FME. So Ably created a custom transformer for us to replicate that tool, which was really helpful. And we've actually used that custom transformer in other FME processes as well. And of course, we have throughout the process emailing options. So our team is notified if there are any failures, and then the super user is emailed of their successes. Moving on to the project takeaways. So using FME, multiple processes have been streamlined into one, and the major benefit of this has been an increase in processing speed. Previously, we would run processes locally on our machines, but with FME Server, we've freed up those machines for other functions. We can also queue jobs on the server rather than waiting for a job to finish on our machine before we process the next job. And in the world of working from home, this has also been really beneficial as we aren't relying on processes running through our home Wi-Fi or VPNs. With FME capturing detailed information on each job around customer, property information, or the user information, we can also now report on the usage of SpreadSmart mapping within Ballance, which we've never done before. And lastly, with this new process and the data being generated being more robust with geodatabase storage, we can take SpreadSmart mapping to the next level and integrate with other business systems. Back to you, Andrew.
Okay, so just as a final summary, just have a few further takeaways around FME and how Ballance use it in general. So FME is still relatively new in the Ballance infrastructure area, and we're still learning about more of what it can actually do. So, however, it has actually allowed our geospatial team to have more options around choosing the processing tools to be used for specific applications. In essence, FME has made our team more efficient and productive. We have a faster turnaround of jobs and job requests. FME also provides us better tools to help debugging issues, which is great when analyzing application defects and in our QAS environment when you've got new projects on the go, analyzing some of the, whether it's input issues or actual application issues. So Ballance is also making a big push into the self-service tools, and we find FME is a great tool to enable the back-end processing for these as well, because there's a lot of there's a lot of different tool sets within it that we can utilize. Overall, since implementing FME, we see it as a heavy lifter of our geospatial data, and it has complemented it and extended our team's offerings and capabilities within the Ballance business. The Ballance geospatial team is actually quite a small team, and we have a mantra to think smarter rather than working harder. FME has actually proven itself to be a tool that can actually help us with that. And so, yeah, we're doing a lot with it going forward. So thank you.
Thanks, Andrew, and thanks, Ruby. Just jumping on here just briefly. We're not going to, please don't stop the broadcast just for now, because we're coming up towards the end of the session, but we've got a few little thank yous that Ruby and I would like to make. But I'll just start by saying Andrew and Ruby from Ballance, not Ruby from Locus. Thanks. It's kind of funny that there's two Rubies here. But look, just to say thanks very much for your time and effort in today's session. I know, Andrew, we've caught up a few times, and it's really awesome to see how Ballance is actually using FME the way that it does. Obviously intrigued by your comments about still learning the software, and I think not quite sure if you would have caught up with the Electra presentation earlier in the day, but I think somewhat of a similar message. It certainly come in and resolved and helped resolve some challenges, and now it's kind of looking forward into what else it can do within the organisation. So, yeah, we really look forward to hearing from you guys again as to what you're going to embark upon next. So, really appreciate your time and effort today.
Thank you.
And look forward to catching up with you soon. I'm just going to hand over to my colleague Ruby now. I might get you to stop sharing your screen if you could, please, Andrew. And Ruby and I have just got a few kind of wrap-up comments, I suppose, in regards to the last 3 days. So, Ruby, let's start with yourself in terms of your comments that you'd like to make. And I'm not sure I'm hearing you here at the moment, Ruby. I think Ruby's just checking there, or potentially just might be me who can't hear her. Angie, am I able to get in the check-in with you that you can hear us okay?
I can hear you loud and clear, John, but I can't unfortunately hear Ruby.
Okay, well, maybe while Ruby's just sorting things out from her end, maybe I can just make a few comments. I'm just going to lift down from here just the agenda for the last 3 days. So that's been it, folks. There's quite a lot of presenters. So in order, actually, I just want to take the opportunity to, first of all, thank everybody who's actually logged in, registered, and attended all the sessions. It's really been amazing to see how many people have registered, not just across New Zealand and Australia, but around the world. So, look, to everybody who has registered and has tuned in, it's just been fantastic to have you here joining us in our 3-day event. We think it's been really cool. We've loved the new platform that we've used, and being able to reach out and connect with everybody has just been really awesome. So I'm just going to read off, because I think it's really super important that we recognise that people have put in so much hard work to make this event possible. So in order, from day one, Mike Obidries from Locust, Callum Smith from EY, Kieran from Locust, Gavin Jeter from Abley, Jan Rogish from Locust, Fuong from QV, Patrick Booth, MC Solutions, Sarah Singh from Wakakatahi, Daniel Knutsford from Morpham, Darren Ferguson, Pip Norris from Locust, Matthew June from Napier Port, Matthew Cooper this morning, Mark Ireland, and Bruce Harold, who stepped into our round table discussion, and our best wishes to Brett, who couldn't make it, but we're thinking of you, mate. Nick Morris, who presented there with Darren this afternoon on indoor mapping, and then finally Andrew Olds and Ruby from Ballance. So look, it's just terrific that all you guys have made the time and effort to put together such great presentations of interest. We've had great feedback from people as to just the quality of them and how interesting they were. And Mark Ireland himself was commenting on just how interesting some of them were. So look, I think you're getting feedback from some really good peers in the industry, and I think everybody should be really happy and proud of the efforts that they've made. From the Locust perspective, I want to say thank you to our team who've put in an exceptionally big amount of time and effort to present. A particular special thank you to Angie Worsley, who has taken this new platform from Accelerant, and really it's become something that I think we're going to use going forward quite a lot more. It's just been terrific to Angie to have your input and to have made all this work so smoothly. Ruby, I can see you back. Not quite sure if you're all set up now. I'll hand it over to you. And I think we might still be struggling a little bit. I think Angie's shaking her head there.
Sorry, Ruby, still no.
Okay, all right. Well, I think, Angie, I think you're giving me the wind-up message there. Angie, any particular thoughts from you before we close down?
No, look, honestly, just what you've said, John, just to sort of acknowledge the enormous contribution that all our presenters have made. And over these last 3 days, I think we've really enjoyed the opportunity to bring this format to our community. You know, as we've said before, in an ideal world, we would be doing this in person, but you know, but we hope that we've done the next best thing, and you know, we feel about certainly the content and the contributions that we've seen over this week.
One last plug for the competitions, of course, if you've attended a couple of the sessions, and Angie's got a feedback questionnaire that'll be coming out soon. So if you can complete that, you go into the draw for winning the 2 driving experiences, which is really cool. Ruby's just sent in a message just to say, look, if you have enjoyed the event, please give us a shout out on LinkedIn. We'd appreciate it, and let me endorse that as well. So yeah, if you can, if you've got some comments to make, that'll be awesome to hear from you guys. So do enter the competition. A couple of great prizes. Thanks once more. I don't think I've forgotten anything else. Maybe just to say, think about heading off to Vancouver for the UC in August. It'd be great to see you guys there. And lastly, if there's any questions whatsoever that's come out of the sessions in the last 3 days, the team here at Locus is more than happy to take in any inquiries. Ditto, I know that Mark Ireland from SAFE is always keen to hear from people as well. So let's keep the community going, and let's share that information. And we look forward to engaging with you guys soon, hopefully in person. And let's hope that Omicron isn't replaced by something else. So until then, thanks from us. Last comment from Ruby. All the sessions, Fiona, you've sent in a question about will the recordings be available, and the answer to that is yes, they will be. So as soon as the event finishes, that's what Angie's going to be working on. So stand by for that information. All right then, thanks again. Great to see you all, and we look forward to being in touch with you all again very soon. Bye for now.
Thank you.